For this section, I'm going to do analysis similar to what they did in the book, but using Excel. So here I've generated some random data that we can play with. This could be anything. It could be the width of a widget. It could be response times. It doesn't really matter. It is variables data because it is continuous, and the precision with which I've measured it is 1/10. Now, if I look at this data, there's not really a lot that I can say about it. I can say it all seems to be in the low 60s. I see as big as 63 and as low as somewhere in the 61s, but they're low in the 60s. But there really aren't a lot of conclusions that I can draw from the data in this format. So if the order in which I made the observations doesn't matter, one thing we might want to do is just sort the data. So I can select the column and say sort the data. And now it's pretty easy to see the lowest thing is 60.6. The biggest one is 63.9. And there are 100 of them, so somewhere around 50. The median is going to be 62. Well, that tells me maybe it's not symmetric. I don't know. It's still hard to draw a lot of conclusions, even with the data sorted. So the next tool that we're going to use to look at this data is a histogram. And you should have seen this in statistics, but I'm going to show you how to do it in Excel. Essentially, a histogram is counts of observations in ranges that are defined by cell intervals. And there are some rules for how to make a good histogram. In general, the cell intervals should be of equal size, and you'd like the cell boundaries to be between possible observations, so there's not a question about which bucket a particular observation should be in. We define the midpoint of a cell to be the average of its boundaries, and if you have a target for what you'd like the center to be, then you should put it as the midpoint of a cell. So I've begun the creation of a histogram for our data. I started out putting in the calculation for the Sturgis rule, and I had it round that to be an integer, and that means that we want to have 8 buckets. I had it calculate the minimum and the maximum of the data, and I'm going to make the top of my histogram be just above the maximum of my data, and you'll see that's because of the way the buckets lay out when Excel creates the histogram. So if that's the top and 60.6 is the bottom, then the range of my data is 3.35. And I want that to fall into 8 cells, so I divide the 3.35 by 8 to get how big should each cell be. Now, when Excel does the histogram, it will put all of the things below a value in a bucket. So I have made the first bucket be at the minimum plus the cell size. So that first bucket will be from this point down. And then I have essentially added the cell size the right number of times so that I get my 8 buckets. Creating histograms is part of the data analysis tool pack in Excel. So if you haven't enabled it, you're going to need to go to Options and look at the add-ins and make sure that this analysis tool pack is active. Once you have that, you will get under the Data tab this Data Analysis, pick Histogram. The input range that we want to do it on is our Data section. The bin range is what we want the edges of the buckets to be. And I'm just going to put it right here on my page. Okay. So those are my buckets. you can see the first bucket goes from 60.66 to 61.0187, and there are two things that fall in that range. And the reason that I had, when we calculated the last bin is below the top of our bucket, that's because they always put this more, which is everything that is above the last value. Now, one of the things that is weird about the way Excel does histograms is that these are just hard-coded values now. So if you look, there is no formula for these values. And in fact, if I were to change the bins or change the data, it will not affect this. So if you change either the bins or the data, you have to tell the data analysis toolpath to redo the entire calculation. Now that we have the data in a histogram, what we'd really like to do is see a bar chart of that data. So I'm going to insert a bar chart, and it's a pretty simple bar chart. And I had the data already selected, so there is my bar chart of my histogram. Now this tells me an awful lot more about my data. It tells me that most often the values are between 61.85 and 62.275, and the data has that one mode, and it perhaps has a little bit of a tail, so it's a little bit skewed, but it's not a lot skewed. There is one more option on the histogram tool that you should be aware of. When I select to do my histogram, there is a checkbox down here for Pareto. If I select Pareto and tell it to put my output in a different place, it'll give me this. This part of it is exactly the histogram that I had already created before. But this part of it, the bins are sorted by frequency. So a Pareto chart is a histogram that is sorted by frequency. And so the Pareto chart always goes down. And sometimes we use that because what we're really concerned about is not so much the symmetry of the data, but the frequency of the most frequent things and what the tail looks without paying attention to symmetry.